Hey guys, today we're going to work on some rules of exponents. We'll start on the page 178 sheet. Um, so exponents are very important in knowing how to manipulate them to work through questions. On page 178, let's start with number 35. So number 35 says we have 6 to the 5th times 6 to the negative 2. Now, if you evaluate 6 to the 5th, that's a really big number. Then we have to multiply it by something else. So with the rules of exponents, when you multiply terms that have the same base, you add the exponents. So it's more common to see x cubed times x to the 4th. That would be x to the 3 plus 4, which is x to the 7th. Because if you think about it, here's 3x's being multiplied, here's 4x's being multiplied. If you're multiplying 3x's by 4x's, ultimately you really have 7x's. So if you just kind of think about it, it'll make sense. But the hard thing about this question is students see the 6 times 6 and they want to multiply them. Don't do it. It's just like this question that has x's for the base. 6 is the base, so it'll stay the base. 5 plus negative 2 is 3. And that's it. And the answer says write your answers using only positive exponents. So this is a positive exponent. So we're done. Number 38. 38 says you have 7 to the 4th divided by 7 to the 6th. Again, it's not really in our best interest to evaluate each of these and then divide. When you divide terms with exponents, you leave the base and you subtract the exponents. So 4 minus 6 is negative 2. Now 7 to the negative 2 doesn't make sense. It's not negative 49. What we do when we have negative exponents is we build a fraction, if there's not a fraction there already, and we move the term with the negative exponent to the other part of the fraction. So since the negative 2 is on the top with the 7, we move it to the denominator, and it's going to be 7 to the positive 2. And there'll be a 1 left in the numerator. So this is 1 over 49. Let's try number 41. 41 says m to the 4th to the negative 3rd. Now whenever you have an exponent raised to another exponent, the rule for that is multiply. And again, if you just think of a simple example, if I have m to the 2nd cubed, I have 2 m's first of all, but I have 3 of those. So if I have 2 m's 3 times, logic would say I'd have 6 of them. So you multiply these. That would be m to the 6. So in our case, 4 times negative 3 is negative 12. We shouldn't leave the answer like this. So you put it over a 1. I always tell my students, think of this as a 2-story apartment building, upstairs and downstairs. The guy living in the upstairs is negative. So, to make him happy, or positive, you move him to the downstairs. He likes the downstairs apartment much better. See, he's positive, and we're left with a 1 in the numerator. So we're done. Let's try one more on this page. What about 47? 47, you have 5w over 6 raised to the negative 2. Now this is a tough one. Be very careful. Everything in the parentheses is going to get this negative 2. So 5 to the negative 2, w to the negative 2, and 6 to the negative 2. Now since all of these have negative exponents, we're going to move these 2 on the top to the bottom, and this guy in the bottom to the top. So it's 6 to the positive 2 on the top, 5 to the positive 2 on the bottom, w to the positive 2 on the bottom. I suppose we could leave this as our final answer, but it would be 36 over 25w squared. All right, let's try some more questions, this time over on page 332. Let's see. Page 332, we'll try number 73. 73 says you have negative 3 e to the 6x raised to the second. Now, by the way, if you're not sure what e is a constant. You could type it in your calculator, 2.718, blah, 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 blah. Let me show you where it is on the calculator. If you look right above the division key, there's a little blue e here. If you hit second division, e is kind of like pi. It's this long, crazy, never-ending irrational number. So what we're going to do, this question is similar to question number 41 up above. We have terms in a parentheses raised to an exponent. So we're going to give away this exponent. So we have negative 3 to the 2. And then e to the 6x to the 2. Negative 3 to the second power is 9. And whenever we have an exponent, like 6x raised to another exponent, again, we multiply. So this is e to the 12x. Let's try 76. 76 says you have a radical. Let's see how this is going to work out. This is the cube root of 27e to the 15x. Let me show you how to deal with radicals. When you take the square root of a number like 9, the 9 of course really has an exponent of 1, and there's a number here called the index. So in this question it's a 3. In a regular old square root without a number, it's a 2. This tells you you're trying to find two numbers that multiply twice to give you 9. So for example, it will be a 3. But you could also rewrite it as 9 to the 1 over 2. 9 to the 1/2. So in this case, we're going to rewrite this question as 27 e to the 15x. That whole thing under the radical is being raised to the 1 over 3. Because if you think about it, 27 e to the 15x is raised to the 1, and then we're putting it over this 3. Then we'll use the rule we just learned or used in the last question. Let's give away this 1/3, 27 to the 1/3, e to the 15x to the 1/3, 27 to the 1/3. If you think about it, I'm just going to go back for a moment. The cube root of 27, what multiplies by itself 3 times, is 3. So 27 to the 1/3 can actually be simplified. 3 times 3 times 3 is 27. I'm going to multiply this exponent times this exponent, so that's e to the, well, 15 times 1/3 is 5x. And let's see, 78. Let's do one more. 78 says that you have e to the 7th times e to the negative 3x times e to the x plus 2. Now because we're multiplying, we're going to add the exponents. So 7 plus negative 3x plus x plus 2, and the base is going to be the same thing that it is, an e. So let's combine some like terms. Negative 3x and x is negative 2x. 7 and 2 is 9. And that's it. So give it a try, guys. Let me know if you have any questions, and have a great day.